Hi, this is the revision video for the 4SI test on rounding and working with fractions, decimals and percentages. Hopefully you've answered or attempted the questions that were posted on Classroom, and here you'll see full explanations of each of the answers. So first of all, rounding to a given number of decimal places. So if we look at these numbers here, we have round 7.819 to one decimal place. So when we're rounding to a decimal place, let's identify where that decimal place is. It's just the 8. So we look at one number after that. So we go to the second decimal place. And if this number is 5 or more, we round up. In this case, it's less than 5, so we round down. So our answer will be equal to 7.8 to 1 dp, one decimal place. That means it's closer to 7.8 than it is to 7.9. The second one is the same number, but we're rounding to 2 decimal places. So the second decimal place will be the 1. So we cut here. The 9 is 5 or more. So that means we round up this time. So this time we get an answer of 7.82 to 2 decimal places. The 1 becomes a 2 because the 9 rounds it up. Final one rounding to 3 decimal places. So the third decimal place is the number 3 here. The 6 tells me I round up. So the 3 becomes a 4. So I have 8.174 to 3 dp. And notice in my answers, the number of decimal places in my answers is the number of decimal places I'm asked to round to. Now rounding to significant figures. A significant figure is the first significant figure is the first non-zero digit in a number, and then all numbers after that count. So if we look at the first one here, we have 236, correct to one significant figure. The first significant figure is the 2. We then look at the 3. The 3 tells us we round down. The 6 has nothing to play with this at all. So our answer will be 200. Our number is closer to 200 than it is to 300. The next one significant figure. The first significant figure here is the 7. The 4 tells us we round down again. So we go to 70, not 70.00 or 70.0. It is just 70. The zeros here, the 0 here is just showing us position. The position of the 7 making it 70. The zeros in the one above showed us that the 2 was in the hundreds column. For the third one here, we round to 2 significant figures. So my first 2 significant figures are 3 and then 5. The 4 tells me I round down. So my answer is going to be 3500. So all of these, they round down, but if any of those numbers after where we cut had been 5 or more, we would have rounded the numbers up. Looking on the right-hand side now, we have quite a big number here, and we are rounding it to 3 significant figures. So we've got 1, 2, 3. The 4 again tells us we round down, so it's 506,000. Those zeros have to be shown to show us the position of the 5, the 0, and the 6. Next ones we go into decimals. The first significant figure is the first non-zero. So here we have 0.0, those don't count. The 6 is the first significant figure. The 8 tells us we round up, so we have an answer of 0.07. Remember, these zeros here are just showing us the position. They're showing us the position in the question of where the number 6 is. It's 600ths, and in my answer, the 7 is 700ths. And then the final one to 2 significant figures. My first significant figure is the 1. The second one is the 9. The 2 tells me I round down. So I have 0.00019. Now converting between fractions, decimals and percentages. So if you remember the little wheel, you have fractions, decimals, percentages. We can turn fractions into decimals by doing the top divided by the bottom of the fraction. From decimals to percentages, we take our decimal and we multiply by 100. And to do percentages to fractions, we put our percentage over 100, and then we simplify if we can. Only one of these is actually reversible. and that is going from percentage to decimal, in which case we just divide by 100. That makes decimals the most powerful form of these three types of number, and we'll see that in the next slide. So doing these conversions here, we'll start with the 85%. 85% as a decimal will be 85 divided by 100, which is simply 0.85. 85% as a fraction is 85 over 100, which simplifies to 17 over 20. The next one I have 0.12. So as a percentage, I do 0.12 multiplied by 100, which equals 12%. And I take my percentage, my 12, I put it over 100, and then 12 over 100 becomes 3 over 25. Notice with that one, we don't go from decimal to fraction, we go from decimal to percentage, percentage to fraction. And the final one here, we have a fraction, so let's turn it into a decimal. So we do 23 divided by 25, and that equals 0.92. And I take my 0.92, multiply by 100, and I get 92%. As I said previously, the most powerful form is decimals, and that's because we can convert percentages and fractions directly to decimals. So when we're asked to compare the size of a selection of percentages, fractions, and decimals, we put it in decimal form. So here we have 62.8. As a decimal, we would just divide that number by 100. We get 0.628. 13 over 21. We do 13 divided by 21. We get 0.619. 0.61 with the dot means it's recurring. Because my other two numbers are written to 3 decimal places, I'm going to do the same here. It'll help me get my ordering correct. So it's 0.611, and I can just make the last one recurring. 2/3 is also a recurring decimal. That is 0.6 recurring, and I'm going to write it to 3 decimal places, so 0.666 recurring. Now I can look at these numbers and put them into order. Well, the smallest number there is going to be 0.611, so that's my first number. The next number will be 0.619, that's my second one. My third one is 0.628. And then my fourth number, my largest number, is 0.666. So what I would do then is, if this was in a test, I would then write them in order: 0.61 recurring, 13 over 21, 62.8%, and then the 2/3. And that would get me all of my marks. You do get some marks for working out the respective decimals, so please write those down. And then obviously the full marks then for putting them in the correct order. So now we're moving on to finding the percentage of an amount. There are several ways of doing this, but I will just show you what is considered to be the quickest way of doing it. And we do it with decimal multipliers. So the first one, I want 7% of 340. Now 7% is 0.07 as a decimal. That's 7 divided by 100. And I take that and I just multiply it by the 340, the amount I want 7% of. Put that into a calculator, and I get 23.8. It's as quick as that. The next one is 56%. 56% as a decimal is 0.56. Multiply it by the 8,200, and I get the answer of 4,592. And let's put the $ in just to make the answer correct. Finally, we've got 18.2%, and sometimes when it's the percentage goes into a decimal, it can get confusing. But you just take that number, divide it by 100, which gives me 0.182, multiply it by the amount, 25,000. Don't be confused here with the comma. That is not a French decimal point. It is an English comma. Sometimes when we see numbers written, they do put them in. I prefer not to have them there, but sometimes you will see that. But you read that number as 25,000. So I do 0.182 times 25,000, and I get the answer of 4,550. Now we have percentage change, so an increase and a decrease. Again, I'll show you the quickest method that we can use for this. If I'm increasing something by 37.4%, that means at the end of my calculation, I will have 137.4% of the original amount. So that as a decimal is 1.374. I multiply it by the amount that I had to start with, which in this case is 7,900, and I get an answer of 10,859.6. You can work out the 37.4% separately and then add it on to 7,900, but this way is quicker. Now, the next one, I am decreasing by 24%. That means I want 24% less. So 100% take away 24%, well, that's going to be 76%. 76% as a decimal is 0.76. So it's 0.76 times 712, and that equals 541.12, and the units here are kilograms. Compound interest is just where we do interest of the same amount repeated multiple times, normally over a period of years, but the period of time could be anything. It could be every month or every day or every bounce of a ball or whatever it is. So read the questions carefully. You need to identify the original amount, in this case it's 2,000, the number of periods of time, in this case it's 3 years, and the percentage change, in this case 5%. Now, we can do this in one calculation. And the way it works is this. We're going to do 2,000, which is the original amount, multiplied by. Now, if I'm adding 5%, that means I have 105% at the end of the first year. So as a decimal, that is 1.05. Now, I'm going to do that calculation 3 times because I'm going to do it for 3 years. So I could write it like this, times 1.05, times 1.05, times 1.05. But that's ridiculous because I'm just doing the same thing 3 times. And something when it's multiplied by itself 3 times is just to the power 3. So I can just simplify it and do that. And then I put that straight into a calculator. And that will give me the answer that I'm looking for. And in this case, it is £2,315.25. Money goes to 2 decimal places. So if your calculation goes to 3, make sure you round it to 2. If it goes to 1 decimal place, round it to 2. Put it as 2 decimal places. Now, your power button should look something like this, either with a little hat. It could be an X with a blob. It could be X to the power Y. It could be a blob to a blob. Each calculator is slightly different. Make sure you understand which button you need to use. But to recap, we have the original amount of money, in this case 2,000. The decimal multiplier to increase by the percentage that we have, in this case 1.05, that adds 5%, and the power of that is the number of years or number of times that you are doing the repeated calculation. So compound interest goes up. Conversely, you can have compound decrease where things go down. But the calculations kind of work in the same way. Again, identify the original amount, in this case 12,000. Identify the percentage change, in this case a depreciation of 25%. That means it goes down by 25% every year. And again, we are doing this over 3 years. It's not always 3 years, so make sure you check the number of years or the period of time that your calculation needs to be carried out. My calculation works in the same way as before. So I have 12,000 multiplied by. Now, if I'm depreciating by 25%, that means I'm losing 25% every time. So 100% take away 25% means I have 75% left, which is 0.75 as a decimal. Now I'm going to do this for 3 years. So instead of doing times 0.75 times 0.75 times 0.75, I'm just going to do times 0.75 to the power of 3, the number of years. Put that into a calculator, and that will give me the answer straight away, which is £5,062.50, or 0.50. Again, making sure I've got 2 decimal places. So the key thing with these questions is to look for the wording. If it says something like depreciates or loses or goes down by, then you know my multiplier will be less than 1 and my final answer will be less than what I started with. If it was increases or compounds or adds more or something of that nature, then your multiplier will be greater than 1, giving you a greater answer than what you began with. So make sure you check your answer relates back to the question and make sure your answer makes sense. And that's it. And good luck with the test.